Hi guys, in this video I'm going to be looking at some properties of logs. So we've learned to evaluate logs, how to write logs in exponential form, and vice versa. And so today we're going to look at some additional properties involving some operations. Okay, so this is just kind of a generic rule that with all these rules, so we have some b is going to be the base in our exponential. We want that to be something positive, okay? Also m, our exponents, n, okay? We want those all to be positive. So this is just kind of a generic rule applying to all these properties. Okay, so the product property, so this is saying if I multiply two powers, right, we know we add the exponents. Well, remember, logs are the inverse of exponentials, and so when I take the log of a product, it splits into addition. It's exactly the opposite. And so notice they have to have the same base when I do that split, okay? So we can go both ways, you guys. We can go from here, if I split into addition, that's called expanding, because now I have two terms instead of one. But I can also go this direction. I can combine and go from addition to multiplication. That would be condensing because I'm going from two terms down to one. So this property works both directions. We're going to use whichever it is to work to our advantage. So for example, in this one, log base 6 of 4. So I'm asking myself 6 to what power equals 4? There's no nice integer answer there. Same with this one. 6 to what power equals 9? That doesn't really help us. Now, because they both are base 6 and it's addition, I could combine this to be multiplication. So it's log base 6 of 4 times 9, which is log base 6 of 36. So now this is something I can evaluate. 6 to what power is 36? 2. Okay. All right. 1/3 to what power is 27? So I always like to think about the reciprocal first and know that I could just make the exponent negative. So 3 to what power is 27? 3 to the third. 3 to what power is 9? 2. Okay, so I actually can evaluate these. Just for the sake of practicing the property, I'm going to go ahead and show what that looks like combining. Okay. So if I do combine, I have the same base. I've got log of 1/3. We can multiply 27 times 1/9. Okay, a ninth of 27 is 3. So we got log of 1/3, or log base 1/3 of 3. So 1/3 to what power equals 3? Again, 3 to what power is 3? 3 to the first. So if I want the reciprocal, I just make it negative. So this would be -1. Okay. Quotient property. Okay, so again, looking at the exponent properties first, as a reminder, when I'm dividing with powers, I'm going to subtract the exponents. I'm going to zoom in just a hair more here, you guys. There we go. Okay. So the log property is the opposite. When I'm dividing two things, I can split it into subtraction and keep the same base. Okay. So let's try that with this one. So I'm subtracting, they're both base 5. So the first one is always the numerator. So this becomes log base 5 of 100 over 4, which is log base 5 of 25. So 5 to what power is 25? 2. Okay. Second one, again, they both have base 7, so we can combine them. Log base 7 of 49 over 7. So subtraction combines to be division. The first one always is my numerator. 49 divided by 7 is 7. Log base 7 of 7 is 1. 7 to the first power is 7. Okay. All right, and our last property we're going to look at is the power property. So again, let's look at the exponent one first. Power raised to a power, we multiply the exponents. Okay, so if I have a power raised to a power with a log, again, it's that relationship of multiplication. So what happens is this exponent comes down in front and multiplies. Okay, so in this one, I'm going to take this 6, bring it down in front, so it turns into 6 times log base 2 of 32. So 2 to what power is 32? That's 5, right? 2 times 2 times 2, 5 times. So this part is 5. So we have 6 times 5 is 30. Okay. This one, same thing. I can actually apply this property, we have a power raised to a power. I can multiply those. So I've got log base 2 of 2 to the 30th. Okay, I'm going to do exactly what I did here. I'm going to bring that 30 out front. So it turns to 30 times log base 2 of 2. Log base 2 of 2 is just 1. So we got 30 times 1, which is 30. Okay, this one, I can do that same thing, pull that 20 out. Oh, sorry. Okay, so I've got 20 times log base 8 of 4. Okay, so this one's a little bit harder, but I'm going to show you kind of a cool trick. Remember, this term I could break into multiple things as well. So 4 to what power equals, or excuse me, 8 to what power equals 4. Nothing super great, but 8 does have a relationship with 2, right? 2 cubed is 8, so the cube root of 8 would be 2. So I'm going to actually split this 4 into 2 times 2. So I'm going to write it like this. So if I use my product property from up above, when it's multiplication, I can split it into addition. So this is going to be log base 8 of 2 plus log base 8 of 2. And again, it's 20 times that whole thing. So log base 8 of 2. So 8 to what power is 2? Because the cube root of 8 is 2, 8 to the 1/3 power. So 1/3 power, 1/3 is the exponent. I'm going to write that down here actually. X to the 1/3 is the same as the cube root of x. So cube root of 8 is 2, or in other words, 8 to the 1/3 is 2. We have the same thing here. So this ends up being 20 times 2/3, which is 40 over 3, right? Okay, so 8 to the x equals 4. This one actually looks very similar. So here's what we're going to do, you guys, is this is kind of the first step in solving. We're going to get to this a little bit more in detail in the coming videos and assignments, but basically if I want to get x by itself, I have to get rid of this exponential of base 8. Well, the opposite of an exponential of base 8 is a log base 8. So I'm going to apply, not multiply, this use the word apply. It's its own operation. We're going to apply log base 8 to both sides, right? Whatever I do to one side, I have to do to the other. So log base 8 of 8 is 1. So I'm left with 1x equals, okay, well now this turns into kind of what I was working with over here. I had log base 8 of 4. We split it into 2 and 2. Which then I could do this process. Okay, so we know that that equals log base 8 of 2 plus log base 8 of 2. So x is 1/3 plus 1/3, which is 2/3. All right. Okay, we got a couple more here. Okay, this direction says write as a sum or difference, then simplify. So we are going to expand. So it can use this direction, or it can say, hey, we want to rewrite it as addition and subtraction. Okay, so this is a product, so we're going to break that into addition. There's 3 different factors here, so we can actually do 3 different logs now. So this is going to be log base 2 of 8 plus log base 2 of x plus log base 2 of y. So it says then simplify. So if there's any log we can evaluate as a single number, we want to do that. So 2 to what power is 8? This is 3. So that would be simplifying further. I can't do anything with log base 2 of x or log base 2 of y because I don't know what those values are. So that would be the furthest simplifying I can do. So just look for opportunities like this where we can write it as just a single number. Okay. On this one, we want to expand. Okay, that's my direction. So remember, division expands to subtraction. So we have log base 4 with the same base. The numerator comes first, minus same base, log base 4 of 16. Okay, here I have an opportunity to evaluate. 4 to what power is 16? 4 to the second power is 16, so we can write that as 2. Okay. Expand this one, I can't write as a sum or difference, but we can expand. That's anytime I can pull an exponent down, that's considered expanding as well. So we have 4 times log base 5 of 25. We can evaluate this one. 5 to the second power is 25, so the log base 5 of 25 is 2. 4 times 2 is 8. Okay, this one I have a product and a power. We want to take care of the exponent first, think order of operations there. So this becomes 3 times log base 3 of 9y. We can split this product into addition. Keep in mind though, it's still 3 times this whole thing. So when I split it, that 3 applies to all of it. So we've got log base 3 of 9 plus log base 3 of y. Oop. So we split that product into addition. Okay, and now check, can we evaluate? Well, right here, we have log base 3 of 9 is 2. So we got 3 times 2 plus log base 3 of y. You guys can leave it like this, or you can distribute the 3, either one. So this would be 6 plus 3 log base 3 of y. So notice I distributed the 3 to both pieces there when I'm distributing. Okay, last one, this is the opposite direction. So we're going to combine to be a single log term. Okay, so here, this is subtraction. Subtraction combines to be division. So we have 1 log base. First number is my numerator. Second number is my denominator. I can reduce 10 over 15 to 2/3. Okay, so that is condensed. Anytime I have a number being multiplied in front, we do want to bring that up as an exponent first before I combine addition and subtraction. So that move that 6 to the power, move that 4 to the power. So we have log base 2 of x to the 6th plus log base 2 of y to the 4th. Same base, so I can combine. Addition combines to multiplication. So we've got x to the 6th times y to the 4th. All right, guys, that's it for this video. Thanks for watching.